Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Peter, who will be presenting on the topic of enhancing business performance through advanced platform engineering. If you have any questions for Peter as we move through today's presentation, feel free to drop them in the chat or use the Ask a Questions tab. Without any further delay, Peter, over to you.
Thank you very much, and we can start. So today's talk is about Jakarta E and as a platform and what it can do for you. So a few words about me. I'm developing since about 87 and started with DBase 3 and C and C++. I'm a big fan of SQL databases, and I'm teaching at the university. I studied at 99 with Delphi, and then we switched to Java applications around 2006-8. We started with Java EE, and last year's we are teaching Spring Boot. Commercially, I'm working with Spring since about 2008. And in the meantime, I spent 2 years working with React.js, and all the time I'm working with Java EE and Jakarta EE as well, as it changed. Yeah, I always was working on web applications, especially after 2000, and I was working in the commerce for product companies, so we were doing something what was sold, some products which were sold, and it was always something I call back office applications, or applications mentioned for the internal applications for bank, for example, some information systems, but never something for more than say million users. So always this kind of applications. And during last years, I became user of Pyra, and last 3 days I joined the Pyra, and as part of this working on the server, I became a committer to Java concurrency, to Jakarta concurrency, implementing it for Glassfish and Pyra versions 3 and 3.1. Good. So today we will talk about business performance. The definition says that it's a company's ability to profit from its resources and achieve its objectives. So this will be the important thing. How with the given resources, meaning developers to achieve objectives, meaning developing applications. What's important for me always is that the customers want to pay for features, so they want to see improving database, improving the application, adding new features, and they really don't want to spend money on just paying technology debt, and they don't want to spend money on upgrading to the latest version of the libraries and so on. So they really want to see new features, and this is what they want to pay for. Also, the customers depend on the software. They pay for it because they make money from it, and it's really important for them. So they really need supported software. If the software has some outages, it's quite disaster usually for them, and so therefore the support is what's the customers very much important. Recently, I heard interesting things about security checks, that introducing some dependencies can cause problems, because this adds another thing to the whole stack, and this is all going through security checks, and the security checks can be quite painful for some customers. I think that just Java has enough, a long list of issues. So interestingly, some of the customers are on the latest version of Java simply because of the least number of security issues. So this is what you will see during the presentation, that this is great match for Jakarta EE, as it provides stability, easy upgrade from one version to newer one. It provides very huge reliability and long-term support, either commercial or open source. If you stake the latest version, they are supported. Uh, Usually the companies are providing newer versions and fix issues when they appear. And we will talk especially about Jakarta EE, about the stability means that the API is changed. It improves, but there is very big push to have backward compatibility. So the API doesn't change very much. If there is something which is dropping, it's usually some scenario which is not frequently used. So developers, once they learn this API, they can use it for a long time and concentrate only on the business logic and not to learn a new API every 2 years. Easy upgrade. I'll show you tooling which is available, and most of this is done automatically. Reliability. The servers which implement Jakarta EE are very heavily tested. There are huge technology compatibility kits and other tests which are running for many hours for every release. And of course, long-term support, which is important for many companies. So they have some running software, and they can run it for tens of years, just unchanged. Okay, so what's happening today when we talk about web development? We talk about huge amount of possibilities we can choose from. It sounds absolutely great. The thing is that at the end, each application is unique. So if you go from one application to the other, you need to learn the whole stack and various things. Today, cloud first and microservices is a must-have. Ideally, break things down to AWS Lambda. Spring Boot is technology standard, and UI is done by JavaScript libraries. I think today the React is the most frequently used, with many other options, but React is the mostly frequently used. API is and data transfer is done in most cases using REST and JSON as a format, and it slowly moves to GraphQL, and there is big race of NoSQL databases. Sounds cool. There are some drawbacks on the reality check. Cloud sounds easy and it brings many advantages. The other side is that it costs money, especially if we are using the managed services. It can use a huge amount of money. The setup is quite complex because you have to set up everything, and for even simple things, it's a combination of, say, 10 various applications to make one running, to support the final application. For application with 200 users, it's absolutely not necessary. Last year, I attended DEF CON, and it was interesting because it was the presenters are sharing that doing microservices and cloud properly is quite difficult, and that actually everything is quite painful. Uh, AWS presented itself that they offer hundreds of services, and the developers have really difficult time to choose the right one, right services, which are really the right solution for their problem. So it's very specialized and quite tough. Spring Boot is nice library. Developers are selecting libraries they need to do for example for messaging, persistence, for logging. They just pick the libraries they want. This makes the complexity when you come to other projects. They very frequently use just different libraries. So it's quite wide range of possibilities. Spring Boot pretty often is introducing breaking changes, so uh, upgrading to newer version is usually introducing some issues. And for applications which are a little bit bigger, like 800,000 lines, this can be quite a big amount of work. And the consequence of this is that there are many. I've seen many old Spring applications which nobody wanted to upgrade, especially in the Spring framework, where the dependencies were really independent from each other. So making upgrade of the Spring application was quite really painful. The next thing, using JavaScript for UI is today a standard. The standard is also Spring page, single page applications, and the motivation to them is to make the application fast. If you look, and I will show some example. If you look how it really behaves, it generates hundreds of requests to the server. The the thing which is solved in the JS all the time is how to deal with the slowdown and race conditions, all this stuff. The biggest problem I see is that you end up with separated teams, and they don't really want to communicate with each other. So the communication is a problem. There is a way how to solve it with the GraphQL, but still there is usually some tension between the teams. And especially for application, and this was always my case, when with every single page, with every single click, when we do something in the UI, it usually means that we need to access database on the server side. So the single page application doesn't bring any value because it still waits to the communication, getting data from the server and return back. Uh, REST and JSON sounds easy, especially comparing to web services, the SOAP web services. Where it went today is, if you open just an example, majority of bigger pages behave the same way. If you open Washington Post, you'll see more than 300 requests to load just this single page, and 80 of them are REST calls. That's one thing. The other thing is that it also introduces a huge security vector, because each of the REST call is possible to test, to play with, to try if this is if it's possible to, for example, do the denial of service on this server and so on. So something what was quite difficult to achieve with server side rendering. NoSQL. They were introduced for special cases when they make absolutely perfect sense. For example, the key value databases scale. That's perfect. Comparing to SQL databases, they are able to scale to very big extent. The issue is uh, that it comes with consequences. For example, you can lose data, and this is something what nobody really wants to talk about, but it's the reality. So it has consequences, and you should know about them. Of course, if the database is bigger than your disk, then you have a problem which you need to solve, and you need to go to NoSQL and deal with the issues. And the last thing is that usually today developers are responsible to package everything to a container and to play with the cloud services, with the Kubernetes, and update all the YAML file, and so on. And also, it's a problem for the DevOps because they need documentation from developers to see how to install stuff. The experience from the field is it comes just broken and nobody really knows. So the DevOps are spending days and weeks trying to figure out how to put everything together. So a little bit issue, and of course developers are spending time on this instead of working on business value. So the question is it really necessary? If you look at Amazon, which came with clouds, absolutely, because if you have something like 600 independent services, you definitely cannot do just a plain server-side rendering, waiting for everything. Because among all the 600 services, something doesn't work, and you need to solve this moving stuff. So something you cannot solve as monolith, for example. So for Amazon, Netflix, and these companies, makes perfect sense. If but let me quote Adam Ben, we don't all work for Netflix. So if you are working on some application for, say, 1,000, 10,000 concurrently logged in users, it's definitely not necessary to use cloud and write it as microservices. So by my side, something between 10 and 100,000 of concurrently logged in users. There is the boundary between what we can do with singleton or say some small set of components, and you need to go to proper cloud and do really proper cloud application. So if you need microservices, if you need cloud, you need to make cloud native application. Full stop. There is no discussion, and I don't know myself any better solution. The thing is, if you don't need this, isn't there a simpler way how to develop? And by my side, Jakarta EE is the way how to make these applications. And at the end, I'll show you how Jakarta can be used even for the microservices. Okay, just an example, one for all. If you have a simple setup, you just log which and it stores the log to file, and you are fine. Of course, it doesn't scale. If you if you if you are working with cloud, you usually install the ELK stack. You install some monitoring. You need to configure everything. You need to also request tracking library to be able to track the various requests among microservices, and then you can log, which is fine. Just the question is, do you need all this if you have only 1,000 users for the application? Is it worth it? On the thing which uh, I'm trying to present here is that uh, Jakarta offers a platform which contains uh, all these services, and the developer can concentrate on only on the business value, on the real application itself, and doesn't need to spend time with other stuff. Which means that the application development is simplified. He doesn't need to concentrate on how I am going to log in cloud, how I am doing track my changes. He simply logs. The same with anything else. If with the platform you want to use messaging, you just start messaging, send messages, receive messages, and the messaging system, messaging software is part of the platform. You don't need to care about it. It's there. It's set up and ready for use. It all together works together. It efficiently uses resources. If the messaging system is not required, it's not started. The scanning of the application just reveals what's used, and these services are started. It's integrated already together, so you don't need to spend time uh, um, configure it. It's the platform also offers to some level horizontal scaling, so you are able to spread the workload over several servers, and it provides load balancing. So it's not necessary to limit yourself to one computer. You can use several. Of course, this is not cloud, so you cannot scale to hundreds of thousands servers. But to the level I'm talking about, some hundreds of thousands of concurrently used logged users. It's useful. And the last thing is security, because the application the Jakarta server is going through some security tests, and if it is supported, if you are using supported version, you will have you are sure that there is no, at least known, security issues. Yeah, maybe you heard about Java EE. So this is something what has very bad reputation. The Interestingly, the idea which came in 99, so concentrate just on the logic and do not look at the server, is something what is alive today. Uh, Actually, every few years there is new project which comes with the same. Spring started this way. AWS Lambda has the same idea. Go with local and remote calls is the same idea. I think that if you look at the WebAssembly, there's the same idea. Just implement what you want and let the rest on the environment. So Jakarta EE doesn't have very good reputation, but it changed around 2006 with Java EE 5, when some microsystems came with the annotations, and it started to be really easy comparing to Java EE 1 to 4, which was quite complex. It was really difficult. I tried to learn it and I failed, but with Java EE 5, this is something I've learned for the first time and I started to like it. Actually, much more than Spring. Yeah. Today it's called Jakarta EE. You know about the issue with Java and Oracle and delivering the Java EE to the community, to the Eclipse Foundation. So today it's called Jakarta EE. The idea is still the same. Concentrate on the business logic and use the application server for the rest. Still, there is the split between the developer who is concentrating only on the business logic and DevOps who is doing the deployment. So, with the application server is actually working DevOps, and developer is programming only to interfaces. An example: when you develop your application, you can use and you need some logging system. Very often on the local and test local machine for development, you can use security realm, which is based on files, so you can very easily create, delete users, everything. And on the deployment on the sites of real user, they use LDAP servers, but the application doesn't change. It just uses the security realm interface, and the implementation is done by the server configured by DevOps. So that's what's quite simple. The setup of the project is just single dependency. The way how EJB, it was the most crazy stuff in Java EE 1.4. Today it's done just by one annotation. So if you ever heard about EJB and being it crazy, today it's just add stateless and you are done. Yeah, servers offer a wide range of APIs. I'll show you the specifications. And it didn't develop for some time, but once it was donated to the Eclipse Foundation, it again started to develop, and it brings quite latest things like Java 21 introduced virtual threads, and today the upcoming Jakarta EE 11 is allowing you to use it. And instead of changing your code, you can only change your configuration, and you start using virtual threads. In fact, you don't need to change your Java code at all. You just change the configuration of the server. There is another set of specifications which come from the time range when Java didn't develop. It's called microprofile, and it's full of specifications and APIs which are very useful for cloud usage in cloud, but didn't get at the time to Jakarta. So today it's being somehow moved to Jakarta, and this is the second piece of specifications and APIs. So the last thing which is missing in the server is your application and your business logic. All the other things are available. If we are talking about security, monitoring, scalability, messaging, various connectors to some external systems, it's all inside, and you just put deploy your application. if you are used to deploy Spring applications, you know how big it is because it needs to carry all the all the libraries, and it includes Tomcat inside and so on. So Spring applications usually tend to be several hundred of megabytes, bigger tens, and several hundreds of megabytes just for this application. In case of Jakarta applications, it's usually like 10 megabytes. If you move some other libraries to the platform, can be just hundreds of kilobytes of your business logic, and that's all. Uh, Jakarta 11, this is the upcoming version, has this amount of you see that some of them were not updated this in this version. Some of them are updated, mostly in pretty backward compatible way. And there is one new Jakarta data. You may know it from Spring Data. That it uses the same approach. Okay, specification, the API you have seen, is something what is composed from specification, just textual description, use cases, how it works, API, uh, which is then implemented by the libraries under the server, and technology compatibility kit. Huge amount of tests which are written against the API and verify uh, every single part of the specification if all the servers behave the same way. So there is very big chance that your application will be running on all compatible servers. So if you like me, if you like Parara, you are developing against Parara, and if the customer for some reason has say Open Liberty, it will run there as well. Yeah. What we offer is also some set of other tools to ease the development. We provide starter. Either Jakarta has its one, or Payara provides its one today with some uh, AI capabilities, so you can create actually whole application just from the starter. I totally suggest to try it. And so you can start very quickly. Uh, Once you learn the stack, you will live with this for a long time. Uh, so you will save time for something more interesting than just a new version. If you are moving from older version to new ones, we provide tools to do the upgrade. The change between 8 and 10 was the change between Java X and Jakarta, so it was the annoying one. So we provide tool which rewrites your code in one single shot. Also, we provide tool for minor changes. So we go through your code and tell you if you are using something what was changed. So you should review this place. So that's quite easy. If you are developing, we are doing something called deploy and save. So you are changing your code, save the code. We have Maven plugin which does the rebuild and redeploy on the server. So you don't need anything. Just wait 1 or 2 seconds, and the server's updated. And one of the things which I really like is that if you have server, and according to our statistics, majority of applications are running on just one server, you can use admin UI to change the settings on the fly, like logging. And if you have a problem, you can go to the logs, increase the level of logging, try it again, look at the log, what's going on, and then return it back. And you can do it on the production very easily. You can also change the configuration, and it's available immediately. Something which is quite nice. Something what you cannot do in cloud, because you cannot change like 100 servers at the same time. Good. Layers, I will very probably go quite quickly through it. I just wanted to show how the development is done. So database layer, business logic, and some UI, not API to the other. So usually, uh, usually the database layer is done by JPA, Java Persistence API, something what you know from any other library. I think nobody else is really using anything else. My personal favorite is generating the entities from database. So what I usually do, I have database and then I generate the entities by myself, the most simple way. And you have this layer done in literally seconds. Then business logic. I'm older, so I'm using EJBs. You don't have to. You can use CDI. So from the UI backend, there is usually CDI used. So you have connections, injections to the EJB. Again, can be still CDI. And the stateless says that it's under transaction, and it can scale, and it includes the security and all the other stuff like scaling. So and you can also have some dependencies between them, and then you use access to the database entity manager. So with very few annotations, you are able to implement it at the full stack. So named, request scope, EJB, stateless, and persistence context. There are 6 annotations which describes majority of the stacks. Most of the things which you need to know. Regarding API and UI, if you are using JavaScript because you just have front end team, it's possible. It's very easy. If you know Spring, the annotations are very similar. The standards were growing next to each other, so they are very similar. Just they have different annotations. It's possible to use JSP or servlet. Some of the basic specifications well known of as well. Something what is a bit controversial, but I like it. It's called Faces today. It used to be called JSF. It's XML based server-side rendering. As I said, every application I ever wrote was using database with every single click. So in my case, no single page application make any sense, because whatever you did, whatever the user does needs to go to the database, render some new information, and display it. And the big advantage is that Faces is technology which is possible to be developed by Java developers. So I already did it several times. We started products based on JSF, and even junior developers were very easily able to develop with it in, say, 1 week of looking into it. And it's not perfect, but I I have to say that it's far easier than to use any JavaScript framework, and also you don't need to take care of REST, because it uses just server side rendering. So just just an example how to generate table is to use data table, and what's nice here is that you directly use via the CDI, you use connection to Java, and here it's just going to property called code on the product, and it generates such table as easy as that. Yeah. So so far we were talking about the platform, and this is something what every single server is doing, implementing these APIs. And what I want to continue sharing is what can be advanced in the platform. So we can go beyond this. So what we can do is to offer convenient configuration, monitoring. We can offer horizontal scaling, some other tooling, and so on. Let's go into it. So what the server offers: easy configuration. You see a screenshot of the admin UI, which allows you to configure every single aspect of the server. It provides security. It provides means to verify your user from local file through database through the LDAP servers. If you want to do anything special, you can create your own module. One of the things which was new in Jakarta 10 was OpenID integration. So another way how to do it. Performance, something which is tested. Database access. In this UI, you can specify database access. You verify that it is working. You configure the you configure the features of the dataset pool, and it's something what the application doesn't need to care. Monitoring, containerization, scaling, and so on. So the configuration is something, for example, micro profile config is something you can change, and the change is visible immediately. Security, various ways how to authorize users. Database access, you specify the connection to the database, and something set up absolutely on the server side and doesn't have any influence on the application, except it just uses that this is the name I want to use, typical JDBC slash name of your application, and it's let on the server to uh, make the connection. Performance. You can specify the something called manage executor service, which is responsible for creating new threads, and you can configure this size of thread pool. So depending on the power of the server and the resources you have, you can change it. There are several types of pools which you can modify. You can also change the logging, which also affects performance and so on. You can switch on monitoring. We have a graphical interface which shows the metrics. Although in most cases customers have their own because they monitor more things than just our server. So we usually provide data for it, and it's part of the customer's bigger setup. If you want, there is a way how to just put together Paera with Prometheus and Grafana, put everything together, and in Grafana you simply see the behavior of the server. the most important thing by my side of the Jakarta is something I today repeat several times. It's the big push on the backward compatibility. So once you write an application, you don't need to change it again. Uh, Keep in mind how long do you support your application. In my case, it was usually something like 10 years and sometimes longer. So application developed in 2008 is something what I see being supported till today without any real changes. The big problem was the JavaX to Jakarta, but again we have a tool which simplifies this, and especially in this case. The people mentioned that in prime faces they changed to attribute names, they had to change some of the dependencies, and with the help of upgrade tool and the ease of upgrading in Docker, just change the version of the server. You are suddenly running on the newest version, and something what makes from 2008 it's 16 years of development without any real problem. If I look at Spring, I think I would need to rewrite it like 8 times in the meantime. And if I had the UI in React, I'm not sure if it existed in 2008 already, but I'm very sure that I would need to rewrite the whole UI several times as well. With Jakarta, just to just these changes. Good. Para stuff. Very quickly going through this. We are providing development tools which help with the integration from IDE to the server. So you usually need only do just one click or even nothing. You just save the file and it's propagated to the server. Sometimes with redeployment, if it is simple like static files, they are just new available on the server and you just refresh the page. We provide the advisor tool for smaller changes, upgrade tool for the big one. We provide dev mode, which is similar what the JavaScript libraries are doing with the forcing refresh of the screen. So you just type save, and in the background Maven recompiles, redeploys, and refreshes the page. Something very easy. The starter I was talking about, it's not very complex, just because everything is always available. So that's nothing really difficult. Yeah, the upgrade tool. Either we have the IDE integration, or you can run just this command, and you have upgraded application. Advisor tool, simple run with this report. I just emphasized what changed. So something you can do. Dev mode, save, and it's refreshed. Nice, quick thing. Containerization. It's not matter of the server, but of course we provide the Docker images, and if you want to use the server, the simplest way, I think the Docker is the best way. Especially, I like using with Docker Compose, which I combine with database, eventually with some other stuff if required, and it's very easy to deploy. We also provide Pyra Micro, which is simplified version of Pyra, so it's more it's better suited for bigger deployments like on the cloud. Scaling, we provide scaling among, let's say, several, let's say up to 10 tens of servers. This is something what makes sense, the horizontal scaling. And if necessary, and you really need cloud, we have something called ParaCloud, which allows users to configure the servers, to configure the deployments and the relationship between them, and through the graphical interface, deploy applications to the cloud in seconds to minutes. Even for somebody who is not experienced with this and doesn't know details of Kubernetes, through this, it's easy. Yeah. So this is something what sits on top of the regions and controls everything in a simple way. So this application looks like this. You just deploy the applications and monitor the number of requests and memories and so on. Just click deploy and run on cloud. Good. Uh, Something from our life. We did a survey and we got quite interesting results. Like 50% of our users uses the last version of Pyra. I mean, at least the major version. So if we hear time to time that only it's used only for old project, which is basically Pyra 4 or 5, it's not true. We have new applications running, so that's nice. Uh, Even last year, a huge amount of users were using latest long-term support versions of Java, which is nice as well. And vast majority is running on Unix. Also, NetBeans and Eclipse are still quite popular for Jakarta development, which was kind of surprise. And also that lots of servers are running in a traditional way. There are some running on the Kubernetes as well. Yeah. One of the things which we need to keep in mind is that as the customers are really dependent on the software, they prefer to have commercial support. So this is something what majority of the servers provide, including us, and this allows them to keep the software which makes millions of dollars every day. This allows them to keep these versions still running. The servers are updated for the security issues, and if they need to continue the support, usually the upgrade is not very difficult, and it helps with the modernization. Yeah. Currently, we are working with the newer version, so using the latest Java 21 capabilities, and we are going to release another alpha release. And I hope that before end of this year or early next year, we will be able to release the final version. So we are looking forward to Pirate 7. And that's all from me. So if you have any questions,
Well, thank you so much for that excellent presentation, Peter. If there is, now is the time to ask Peter some questions as we wrap things up. So we are actually looking for some more tech talks throughout 2025. So if you are interested, please do so. I will provide the link on how to complete that in the chat. So let's take a look, Peter, and see in the questions. There is no questions, or there is nothing in the chat. Thank you so much for the excellent presentation, and you have yourself a wonderful day. Take care.
thank you. Goodbye.